Hello. I wanted to go over a few examples with application of right triangles, especially when it's talking about angles of elevation. So here's the first example that I have posted. We have a Niagara Falls, which is the waterfall here that we're trying to find how high is the falls from here to here. We have a small boat going downstream. Here's the 2,500 feet, and it has a angle of elevation at 4 degrees. So anytime you see angle of elevation, you're kind of looking up. So here's the Niagara Falls, the guy from the boat looking up here. So look at the information that we have here. We have the angle, we have a side, a missing side, and another side here. So we have to go back to where we talked about Sakatoa, where we have sine over opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent over hypotenuse and adjacent. And we got to use the information given and ask ourselves what information is given and what do we have? Well, I have a side and I have a side, but do not have the hypotenuse. So sine and cosine is not going to help us with this problem. That's why we're using tangent. Opposite, so here's the angle we're talking about. The line is opposite here. And then we have the adjacent part, which is here. Anytime the number's on the bottom, we take both sides and multiply by this denominator. We multiply 2,500 times tangent of 40 degrees, and we get this answer here. Here's another example where we have the information here and here. Here's my right angle. I do not have the hypotenuse again. So this means that we're going to be using tangent again. Opposite over adjacent. Here's my angle. Opposite goes on top. Adjacent goes on the bottom. This time, since the x is on the bottom, the easiest way to solve this problem to solve for x is just take this whole tangent 7.5 degrees and put it underneath 325. That gives us this x here. So for this one, we'll multiply both sides by the 2,500. If it's on the bottom, a number is on the denominator. And here is where we divide now this whole guy underneath the number. Let me give you another example here of angle of depression now. So John is sitting in a tree, so he's up here looking down at Jake, which is down here. The angle of depression, he's looking down now because depression, elevation is up, depression is down. We add 42 degrees. Well, we know this from here to here makes a 90-degree angle. So here's my 90-degree angle. If this is 42, then this must be 48. Here's my 90-degree. To let you always know, anytime we're talking about angle of depression, this angle here will always be equal to this angle down here. Because this angle is 48, that's 90 degrees here, and that's 42 because they match. And they'll always be equal to each other, these opposite angles here. So since I have this degree, which is 42, I have this missing side, and I have this side here. I do not have the hypotenuse again. So guess what? I'm using tangent because tangent doesn't need the hypotenuse, only cosine and sine does. So here's my degree of 48 degrees, and then I have the here's the opposite over adjacent, and we solve for the angles here. So all these examples here will help us with solving for the Sakatoa with angles of depression and angles of elevation.